Today we will talk about AI and specifically conversational AI. And to get a feeling, because I missed the introductions about everybody heard of the term AI, but who actually thinks is from, or who is from the technical area and knows what AI is? Can that person raise their hand? Nobody. Okay. So it's important, first of all, to understand what AI is. AI, obviously, literally, it means artificial intelligence. And let's just say that the marketing guys really hyped up, especially in the recent years, artificial intelligence. Because if you look at the word, it's only two. It's artificial, which is like a computer, let's say, and intelligent, which means an intelligent kind of form. It should be an intelligent machine. That's what you think from the two words, right? But if we look at devices, I'm looking to see one. I don't see one. But let's say there is an intelligent light switch on this wall. And this intelligent light switch, well, what can it do? It can switch the light, right? And it can do it intelligently. So that means the intelligence in that light switch most likely is something like, if I pass the light switch and the infrared eye sees me passing, it can switch on the light. Well, that's it. It probably switches off after 10 minutes, and if I pass again, it can switch on the light again. So the intelligence in an artificial device is, let's just say, pretty limited. It can do things, but that doesn't mean it's intelligent. Intelligent in a way like we humans are intelligent. We understand, we have conscious, we have emotions, we have logic, etc., etc. Basically, these things do not exist in artificial. So if you think and if you hear about artificial intelligence learning by itself, humans think that, okay, he's learning like me, like a human. Well, you already understand that is not the case. It can kind of learn, but not like a human, because it needs feedback. Feedback, also humans learn from feedback. The typical example that I give is if I walk here and I hit my leg on the chair, my brain gives me feedback through pain, and it tells my body, don't move the body against this piece of wood because it hurts. Not because it hurts, you can't go there. And the feedback sensor itself is pain, which tells my body, okay, don't go there anymore. Maybe next time try to go around it. Now a human has learned through the feedback sensor of pain that it should not try to touch this object because it's painful. In artificial intelligence, if people say it is self-learning, it is actually storing the feedback that it got from any of the sensors that it can get and trying to do something different next time. Now, humans also have a very important part, which is called logic. If I want to move from here to this door, and the first time I try to do it in a most short way, I notice I can't because I get feedback from my leg. Something is obstructing my path. A computer typically, like here, I got the feedback here that I moved too far, so I know and I need to move a little bit to the left. If a computer needs to go from here to there, it's basically going to try every path around these objects. And if it doesn't have a second sensor, which is an eye and logic, I can see this is the same material, same color, same everything. So I already understand if I try this path, this whole path on the right side from me to the door is already locked out. If a computer doesn't have those sensors, basically an eye and logic, and understand that it is wood and it is, it's obstructing my path, it will just try every way. This is something you probably saw in computer simulations where something moving, or a ball, a pointer on the screen moving, and it tries everything, and until finally, after a million iterations, it understood, okay, this is the path. Now this logic part and the sensors that humans have, they are not available for computers. And then I think if you have all those sensors, then still we have a brain, and the brain, yeah, we don't understand really how the brain works. So we're far from AI replicating humans. Well, replicating, yes, but they're very stupid. They're still not logical. They still don't have emotions. They still have no logic. So if we talk about AI, it is artificial. It is a computer. It can't think. It won't think for a very, very long time. At least that's my belief. But it is very efficient. Once it knows how to do anything, it will do that very fast, very efficient, and it will be the most effective way to do that single task. But it is a single task. As soon as the parameters of that task change, because the chair moved, everything is gone, and the computer needs to start over again. It doesn't have logic to understand, okay, the path here is obstructed, now I need to do one path to the right. It will try all the paths here, and not just take one in the middle. So that is a little bit what I wanted to explain about AI. Remember, very efficient, but not really intelligent. Although the intelligent word is in the description, I understand that. If we talk about conversational AI, it is the part of AI that tries to replicate conversations. Back to the light switch has a single task: switch on the light, off or on, that's it, that's the thing, what the thing can do. So conversational AI can only do conversations. It's built for analyzing and replying to conversations. It can't see images, or it can't do other stuff. That's another task, another rule set, another environment. And the most important part in conversational AI are two terms. If you ever get to AI and to investigate, you will see NLP and NLU. NLP is natural language processing. That's basically understanding the language. I would say the best example of NLP is translation services on the web. Google Translate, Baidu Translate, any translation service. You input a word or a sentence, it processes the text, it gets it from the other language and gives you the translation. That is natural language processing. Another example of natural language processing is that you take the word and search that word into the database and gets its explanation. It's like a dictionary, basically. So you search for plant, you get the description, green, live form, I don't know, with roots, I don't know. I don't know the definition actually of a plant. But anyway, computers can do that. They do that through natural language processing. That's a thing that you need in conversations. The first, you need to understand what the text means. Then there is another, you need to know what the text means. Then there is another part, NLP, I said NLU, it's natural language understanding. So even if you know every description of every word, it doesn't mean you understand it. Understanding a sentence, I want to sit, you already some concepts that you understand. If I say to you, hey guys, I want to sit, you probably think, okay, he's going to sit here because this is the chair, there is a chair on which he can sit, it is near to him, so most likely he will choose this chair to sit. NLU, in computer terms, is basically, it dissects the sentence and it can tell me in metadata, this is in a feedback to my response, it will feedback to me, okay, He wants to go sitting. So there's an action, and there are two actions. He wants to go and he wants to sit. So he moves down to sit. That's called an intent in AI. So the intention of me expressing I want to sit basically means I go here and sit. In an AI environment, in conversational AI environment, what I would do as a developer or somebody that wants to utilize the AI itself, I will take the input from the end user, basically you talking to a computer, I want to sit, I take that sentence, I give it to the AI, that is the input. The output is multiple forms. It's basically a little database that I get back from the AI. It tells me intent, sit. Object, him, like I. Confidence score, which is very important, 80%. Emotion, if it can detect, it also gives me a score. So the confidence score that I get back from any AI, can be Google AI, can be Facebook AI, can be Baidu AI, they all give confidence. That gives me, as a developer, an insight on how sure the AI is about what I asked. So basically how sure it is about its own answer. Based on the response, sit, it tells me the goal is sit, intent is sit. I need to prepare a next step in the dialogue. So if we talk about conversations, it has a start and it has an end. In conversational AI, which is often used in a chatbot or some chat object on a website or in an app or anywhere else, it has a start and an end. Start, well, there are very few starts, but basically it starts with hi, hello, etc., etc., etc. These are we call this starting intents. So even the hi that you express to, let's just take the chatbot as example. That hi will be passed to the AI, and the hi will immediately, the AI will immediately tell me that's an opening. It wants to start the dialogue. And it'll give a 100% confidence score. I mean, there's no, it's one word, it's very obvious, it's the first word in a most likely conversation, so it's 100% sure this is opening and he wants to start the conversation. The end is actually multiple, because you have one start, which is the hi, but you still don't know where the conversation is going to. So in a conversational design, you basically have a big tree of all the possible endpoints in your conversation. And this is where it gets challenging and difficult for companies, you and brands to utilize conversational AI. Because Google can say, well, we have basically any conversation you can have, we already have it stored in the database, so we know which path you need to take, and we are 100% sure about every score that we can give you back, 100% conversational score about any sentence that you ask. So okay, but I'm my company, I'm MQ Coffee, and I have specific environment. I have the environment here, I have two pillars in the middle, I have these chairs, I have my brand of coffee, I have my type of beans. So it would be almost impossible for an AI vendor to answer questions about this place, because they don't have data about this place. They don't know what type of coffee beans are used. They don't know how many openings to the back there are. They didn't know there was a bar here on the left. So any vendor that tells you, yeah, but we can do all your conversations, well, that's highly unlikely, to say the least, because they don't have the parameters or the data about your specific environment. So if you think about your company, you have a product, you have delivery rules, you have parameters on every product. If you have multiple products, you have parameters on that product. So let's say you sell coffee, which means you use beans. which beans have a taste, they have a color, they have a perfect brewing time, etc., etc. These are all the parameters on the same coffee. Then you have multiple coffees. You have black coffee, you have latte, you have a cappuccino, each with their own set of parameters. So if a user starts to talk about product, I'd like a coffee. If I give that to the AI, it will tell me he, coffee, intent, drink coffee. A logical next step in the conversation, also as a human, would be what type of coffee would you like? Do you like a cappuccino? Do you like a latte? Do you like a black coffee? We can select. Then the next question would be, would you like it hot or would you like it cold, right? And maybe you want a big one or a small one. So all these questions and answers you can actually plot in a tree, in a decision tree, basically. Because it is high, first step, I want a coffee. What type of coffee do you want? You want it hot or cold, and you want it large or a small. All those possible selections, you can put them in a graph or in a tree and feed them to the AI. Because the AI, it doesn't have any knowledge about coffee beans. It doesn't have the knowledge of concept of hot and cold or big or small. If I take this coffee shop as an example. So if you try to replicate that to yourself, to your own business, you can already understand that there are many possible trees on all the products or services that you sell, and then all the possible questions on it. This is what we call training of the AI. How you would start is you would have all the possible answers. You need to have the data on all the possible answers that you can give about your product or your service. So basically all the questions. And you map them into a tree. Why you map them into a tree is because later you need to understand how the AI is used. And you have multiple layers. Like I already said, you have your company, you have your start, maybe you have product and services, already two trees. One thing is about physical things, one thing is about services. If you have products, well, next, obviously, these are your products. It's like, let's do an electronics company. You have TVs, you have shavers, let's take Philips as an example, which is one of our customers. You have water cookers, okay, all these products. And then all these products can have multiple different questions. If I'm talking about a TV, there are a different set of parameters. There's a remote, there's an on-off button, there's color, there's reception, there's input devices or connections, etc., etc. But on a water cooker, it's completely different. Well, the on-off is the same. Then I have a volume, I have a temperature, now all these possible questions. I need to feed the answer to the AI. By doing and moving everything structured in a tree, I can set up some kind of insight and reporting for myself. Because obviously, if the question is about products, I put something of the name product in the reporting label. Let's call it a label. I have services, I have different products, so the product name will be there. Then maybe some part on a small detail of the product. Let's say if it's a TV, it's the screen, the remote, the power supply, etc., etc. So later, if I'm feeding all kinds of conversations to the AI, for every sentence that it gives me back, it will also put that label of that answer on top of it. So if I store all that information of all the conversations in a big table or database, later I can compress, I can remove the content, merge all the same labels into one, count, if you use Excel, and then I would understand, hey, if I count all the products, TV, power supply, I have 10, but if I count all products, water cooker, volume, I have 5. I can already understand that there are more questions about TV than about the water cooker. And this insight, if you do this long enough, you would start to want to investigate the number of conversations about, let's say, TV, product, remote. If that is a very high number, maybe there's something wrong with the remote. Because a lot of people, if you talk about customer service, are talking about this remote. And this is how you get insight for a big company, what's going on, for instance, on your customer service, by just counting the numbers of parts of conversational tree and investigating them. Because in the end, like I tried to explain in the beginning, an artificial intelligence cannot understand what is going on. It cannot make a logical, it will not help you to make a logical decision because it's very logical, but it doesn't have any real human intelligence. But if there is a question about the remote button A or B, it can find it very fast and it will just present always the same answer. Another big helpful part in AI is that it understands context. As soon as I go into a conversational tree, I can also set the context. And the AI will remember the context on my conversations. Let's say you do a joke generator. So every time the input is tell me a joke, AI understands, he wants joke, tell, I have a database of 100 jokes. I will go into the tree, take one of the jokes on the database, give it back to the user reads it, maybe he's happy, maybe he's not, doesn't matter, I give the joke. Now, if as a user I would type, give me another one, and I give it back, you in your mind already made the logical decision. If he says, I want another one, he wants another joke. Because the context was, we are into jokes. So this is a very important feature of an AI. It remembers what the context of the conversation was. So if the user inputs another one, it immediately understands, well, the last time was a joke, so I need to do another joke, and gives back a joke. Now, you already understand these are very limited parts of intelligence. It can understand context, it can understand intent, what want the user to do, and it can understand topic, and it is very strong in labeling. But that's basically what a conversational AI can do. If we go back to the reporting, by reporting and not just counting, we can actually graphically now also display conversation paths, because still remember that tree, you start with hi and you have all your possible answers. Now you can visualize the number of conversations in each path. If you give them another color from green to red, you already understand that red would be a very busy path and green would be a less taken path. So you can actually see visually in a graph, if we talk about customer service and conversations, where the busy part of your company is. And as a manager or analyst, you can already tell yourself, okay, maybe we focus on all the red paths because we have a lot of conversations about it. Maybe we should optimize something there. The last part in conversational AI is basically, I don't understand what you get. There's no answer on the input you give me. And I'm sure if you all tried a chatbot or a conversational AI, that thing would have responded to you, sorry, I don't understand. Can you use different words? Basically, it tries to get another input from you to search again in the database to see if that was trained, basically, to him. This is also a very important part in AI to mark that input as basically unresolved or not match or whatever the AI is giving back to that. Because this part, all the answers or all the inputs that were given to the AI but had no answer, also need to be resolved by training the AI, giving more input to the AI to resolve those questions, basically, inputs.